We'll be taking a look at functions. So we have this thing called an ordered pair where we have the x and the y. Our x is going to be our independent variable, and then our y is going to be our dependent variable. An example of this would be 3, 10.50, where we have 3 gallons of gas resulting in 10.50 for the amount that we need to pay. So next thing we have is a relation. A relation is a set of ordered pairs, for example, 8 and 28, 10 and 35, representing the amount of gallons of gas and the prices that we're going to have to pay. A function, on the other hand, is a relation in which each of the distinct values for the first component of the ordered pair, there's exactly one value of a second component. So we'll take a look at a couple of examples to see if these relations define functions. So for the first example, we have -4, 0, -3, 1, and then 3 and 1. So let's go ahead and write our x values here. Our x values are -4, -3, and then finally 3. Let's go ahead and map our y values out. We have a 0, a 1, and then finally another 1. And these will be our y values. And then we want to see what it's mapping to. So the -4 is going to map to the 0, -3 maps to the 1, and then the 3 maps to the 1. So we have an x assigned to each of the y's. So we'll go ahead and say that m is a function. Our second example here, we have some more numbers in ordered pairs. So again, let's write out our x and y values. We have a 2, a 3, a 4, and then a 5 for our x values. And then our y values, we have a 3, a 2, a 5, and a 4. And we'll go ahead and look at the mapping. So 2 goes to 3, 3 goes to 2, 4 goes to 5, and then 5 goes to 4. So again, this one is a function. So we'll say n is a function. Now our last example here, let's go ahead and look at p. So p, we have our x and y values one more time. -4. And then finally we have a 3, a 6, an 8, and then a -3. Okay, so we can go ahead and reduce this just a tiny bit because we have the -4s repeating. So this is actually going to be equal to a -4, a 0, and a 2. And then we can go ahead and map these. So if you notice, the -4 maps to our 3 here and a -3. So we have our x value mapping to 2 y values instead of 1 to 1. Our 0 goes to a 6, and then the 2 is going to the 8. So this one's actually not a function because this -4 is going to the 3 and the -4 is going to the -3. So we can say p is not a function. Now we'll move on to the domain and range. The definition of domain is the set of all values of the independent variable x, and then our range is the set of all values of the dependent variable y. And how do we find these? Well, we'll go ahead and take a look at some examples of finding our domain and range. So for our first example, we see, what are our x values? Well, our x values are right here. So we can go ahead and write our domain out. We'll say a -4, -1, 1, and then 3. And then what are our y values? Well, our y values, -2, 0, 2, and 5. Writing these out, -2, 0, 2, and 5. And now we'll have to recall a little bit about our functions. So notice how we don't have any x values mapping to two y values in this case. So we can go ahead and say that this is a function. For example 2, again, what are our x values? Our x values are 1, 2, and 3, and our y values are 4, 5, 6, and 7. So go ahead and write those out. 1, 2, and 3, and then your y values of 4, 5, 6, and 7. Now one thing to note here, look and see that 2 maps to the 5 and 2 also maps to the 6. So this one's not going to be a function. Okay. Example 3, looking at it in a little bit different way. We have our x values again, -3, 0, 3, and 5. And then our y values are all going to be 5s. So domain, go ahead and write your x values out. -3, 0, 3, and 5. And then what's your range? Your range is only going to be 5. Now this might be a little bit tricky for the function, but notice how each of the individual x values are mapping to a 5, but we don't have one of the x values mapping to two different y's. So in this case, this is going to be a function. Now, how do we find our domain and range from graphs? Well, in this first example, we have some ordered pairs plotted on our graph here. All we have to do is list out our x values and then list out our y values. So let's go ahead and take a look here. What are our x values? Well, we have -2, a -2, a 4, and a 4. And we don't need to write the repeat numbers. So going from smallest to biggest, we have a -2, comma 4. Now, what are our y values? Our y values, we have a 3, a 0, and then a 3 and another 0. So go ahead and write them out, smallest to largest, 0, 3. Okay, same thing with B. Let's look at it. Our domain, now think about this. Our domain in this case are all the x values, but we know since we have our arrows here, it's going to keep going on for infinity. So it's going to keep going this way to infinity and this way to infinity. So what is our domain? It's going to be -infinity to +infinity. Same thing with our range, right? Our range, it's going to keep going up and it's going to keep going down forever. So our range is going to be -infinity to +infinity. Two more examples here with some different graphs. So let's write our domain. First thing we want to do is look at what our x values are. So our x values, notice how the furthest we go to the left is going to be a -5, and the furthest we go to the right is going to be a +5. And then the lowest we go on our y-axis is our -3, and the highest we go is a +3. So in this case, since we have a filled in little dot right here, our domain is going to use square braces like this, -5 to +5. And same thing with our range, -3 to +3. Okay, now for D. Let's look at our domain and our range. So our domain, in this case, all of our x values, so it's going to keep going to the left to infinity, and it's going to keep going to the right for infinity. So we can go ahead and write our domain, negative infinity to positive infinity, and then our range. The tallest we ever go is going to be this 4 here, but notice how we keep going down for infinity. So in this case we'll have negative infinity all the way to our positive 4. So a quick agreement on domain. Unless specified otherwise, our domain is a relation that's assumed to be all real numbers that produce real numbers when substituted for the independent variable. An example of this could be y is equal to 2x plus 3, where x could be all the real numbers that you could plug into that specific equation. Another helpful tool is our vertical line test. For every single vertical line where it intersects the graph of a relation, it can't do that more than 1 point. And if it does, then it fails the test. But if it only crosses your graph in 1 point, then it'll pass the test and it will be considered a function. So we'll go ahead and take a look at our examples above that we were just looking at. So using that vertical line test, let's take a look at these. Notice how if I were to draw a vertical line, it's crossing these 2 points, and then same thing over here. So let's go ahead and write, is this a function? The answer is no, because it crosses in 2 points. How about this other one? If I were to draw a vertical line, it doesn't matter where I draw it on this, it's only going to cross at a single point. So is this one a function? The answer is yes. How about C? If I were to draw a vertical line, see, there is a point where I can draw it and it'll cross at 2 individual points. Yes, I can draw it here, but if there's any case where I can draw it and it crosses more than 1 point, then it fails the test. So this one is not going to be a function. Okay, our last one for D. If I were to draw a vertical line, notice how it doesn't matter where I draw it, it's only going to cross at a single point. So we can go ahead and say this one is a function. Okay, moving back down, we'll look at identifying functions, domains, and also their ranges. So our first example we have here is we want to determine if a function given a domain and range. So we have our equation y is equal to 2x minus 5, and we want to determine, is this a function, what's the domain, and then also what's our range. So this one is similar to the previous problem we looked at. Our domain, notice how we'll continue going to negative infinity and positive infinity for all of our x values. So our domain here, negative infinity to positive infinity. And same thing with our range. We'll continue to go positive infinity for y values and down to negative infinity. Doing that vertical line test, notice how it doesn't matter where I draw the line, it'll only cross at 1 point. So this one is going to be a function. Looking at B, x squared plus 3, we have our graph on the right hand side. We can start with the function or the vertical line test. It doesn't matter where I draw our vertical line, it'll only cross our graph at 1 point. So yes, this is a function. And then our domain, for our domain here, we're going to continue to go to negative infinity and go to positive infinity for our x values. And our range here, our lowest point is going to be 3 but it's going to continue to go to positive infinity for our y values. So we can say a 3 all the way to positive infinity. Now we have C. We have x is equal to the absolute value of y and our graph over to the right hand side. Doing our vertical line test, notice how if I were to draw a vertical line here, it's going to intersect at 2 individual points. So this one is not going to be a function. And then our domain, we have 0, 0 here, and this is the furthest left we'll go for our x values, but we'll continue to go to positive infinity all the way to the right hand side. So we can go ahead and say 0 and then all the way to positive infinity. Our range, let's see what our range is looking like. Our range is going to continue to go from negative infinity all the way to positive infinity for our y values. Our last example here, we have y is greater than or equal to negative x, and our graph over to the right hand side, we have our solutions above this specific line here. So our function test, is this going to be a function? Well, let's see. If these are all our solutions in here, if we do a vertical line test, it's going to intersect at multiple individual points within here. So this is not going to be a function. Our domain, we're going to continue to go to negative infinity to positive infinity. And same thing with our y's, negative infinity all the way to positive infinity. In example E here, we have y is equal to 3 divided by x plus 2. Let's go ahead and do our vertical line test. Notice how it doesn't matter where I draw a line, it's only going to intersect this at one individual point. So the function, yes, it is a function. Our domain, this one's going to be a little bit different here. So notice how our domain, we're going to go all the way from negative infinity, and then we're going to get really, really close to this line. And this line is at negative 2. So we will have a negative infinity to negative 2, and then we'll use this symbol called union, which means we're going to go ahead and include another set of solutions. And then we have negative 2, and then we'll continue to positive infinity. Okay, our range. It's going to be a little bit similar, but this time we have to think about this a little differently. So we're going to come in from negative infinity, and then we approach this line in the middle, which is 0. So we have negative infinity to 0, and then again we'll use union, and then we start at 0 and we go all the way up to positive infinity, and that's going to be our range. Next we have the variations of the definition of a function. So function is a set of ordered pairs in which no first component is repeated. And then a function is also a rule of correspondence that assigns exactly one range value to each distinct domain value. Our function notation here, we have y is equal f, and then in parentheses we have an x, or y is a function of x. So say for example we have an equation y is equal to 3x minus 5. We'll go ahead and replace this y with the f of x, which gives us our function notation of f of x is equal to 3x minus 5. So now implementing this function notation, say for example we have f of x is equal to negative x squared minus 6x plus 4, and then g of x is equal to 3x plus 1. We want to find each of these. So f of x, or f of negative 3, go ahead and find your equation that corresponds with the f. So that'll be this equation, and then go ahead and plug your -3 in. So f of -3, this is going to be equal to a negative, and then -3 squared minus 6 times -3 plus 4. And then if we simplify this a little bit, we'll have -9 plus 18 plus 4, which is equal to a 13. Again, we'll use that f of x equation, but now we're plugging in r. So this will give us a negative and then an r squared minus 6r plus 4. And this is going to be equal to -r squared minus 6r plus 4. Now we'll go ahead and implement the g. So g of r plus 2, go ahead and find your g of x. And now we'll be plugging in r plus 2. This will be 3 times r plus 2. And then we're going to go ahead and add the 1 on the end. So this will be equal to 3r plus 6. And then that's going to be equal to 3r plus 7. For our function notation, more examples, we want to find f of -1, where f of x is equal to 2x squared minus 9. So go ahead and plug your -1 in wherever you see x. So f of -1, that's going to be 2 times -1 squared minus 9. And this will give us a 2, because -1 squared is a positive 1, minus 9, or -7. B, find f of -1 where we're given these ordered pairs. So we want to figure out what's f of -1. Well, go ahead and figure out where your x is. So -1 right here corresponds to a 6. So f of -1 is going to be equal to a 6. Now we're given a domain and range. We have a domain, and we want to figure out what f of -1 is going to be. F of -1, go ahead and find your -1, and that corresponds to a 5. D, we're given f of -1, and we want to figure out what that's going to be equal to. So f of -1, -1 for our x value is right there, and what does that correspond with? Well, that's a 0. So f of -1 is equal to 0. Now we'll look at finding an expression for f of x. Consider an equation involving x and y, and assume y can also be expressed as a function f of x. So to find this, we have 2 steps. Our first one is to solve for y, and then once we've solved for y, we want to replace y with f of x. So writing our equations using function notation, say for example we assume that y is a function of x, and rewrite each equation using the function notation. So we want to find f of -5 and f of t. Our first equation, well, what do we want to do for our 2 steps? First, we want to solve the equation for y, and then we want to replace y with f of x. So looking at A, we've already solved for y, so now we need to go ahead and replace it with f of x. So f of x is equal to x squared plus 2x minus 3. And this also asks us to find f of -5 and f of t. So go ahead and plug those in. This is going to be equal to -5 squared plus 2x, 2 times -5, and then minus 3. And that's going to be equal to 25 minus 10 minus 3, which is equal to 12. So now let's go ahead and look at increasing, decreasing, and constant functions. So looking at our graph here, we have -2 to a +1, and this is going to be increasing. And then from 1 to, looks like 3, we have constant. And then the last thing, from 3 to 5, we have decreasing. So where is it increasing? Well, looking at our graph, we have increasing from -2 to 1. So go ahead and write that in. -2 to 1. Constant from 1 to 3. And then finally decreasing from 3 to 5. How about this one? We have increasing from -infinity all the way to -1. So go ahead and write that. Increasing from -infinity to -1. And then we have decreasing from -1 to -2. -1 to, actually it is a +1. And then finally we have constant from our +1 all the way to +infinity. So looking at a word problem here, we have a similar graph with gas over time and then our gallons of gas. So for our first minute, we're increasing. And then from our minute 1 to minute 3, we are decreasing. And then finally, we remain constant from 3 to 4. So we can go ahead and answer our questions here. When is gas changing the most rapidly? Well, it's changing the most rapidly from 0 to 1. Notice how this curve is pretty steep versus this other one. So we can say changing most rapidly from 0 to 1. And then our unit is going to be minutes here. After how many minutes does the gas decrease? Well, our gas starts decreasing after 1 minute. So we can say after 1 minute it starts decreasing. So 1 minute. And then our final question here, how many gallons remain after 3 minutes? So 3 minutes, it looks like we have 3 gallons of gas remaining at 3 minutes. So 3 gallons.